Okay, so let's kick this off. Hello, I'm Camila Crispim. I'm lead technologist here at Thoughtworks. I'm based in the Recife office, one of our 4 offices in Brazil. And today I'm very pleased to be joined by Martin Fowler, the chief scientist here at Thoughtworks. And I'm pretty sure you all know him, and that's probably why you were here. But perhaps, Martin, could you tell just a few words about yourself?
Yeah, I'm primarily a technical author and speaker these days, focusing on trying to gather what I can about what makes good software development practices, particularly from my colleagues at Thoughtworks, and present them to the wider world. And for the last couple of years, my primary writing exercise has been revising the refactoring book that I originally wrote about 20 years ago, and I felt was could do with a bit of a dusting and a redo, so I have been doing that.
Cool. So you know, Martin and I will be talking about the 2nd edition of his book, Refactoring, and you're going to be touching a little bit other themes around the refactoring itself. So I've brought some topics myself, which I'm keen to hear from Martin, but I'd like to invite you to do the same. I bet you also have questions, so use the Q&A section in the Zoom webinar to make your question, and we will be also using the upvote facility. So in case someone makes a question that you are also curious about, you please give your vote, and that's gonna help us to prioritize the questions that gets answered. And you know, we're gonna try to answer as much as we can. We won't be monitoring chat, and I mean Martin and I, so please do use the Q&A section. So Martin, to kick this off, why don't you start telling us why you decided to do a 2nd edition of the book?
Well, it was really a reflection of the fact that the book has been around for quite a long while. In some ways, it didn't really need to be changed because the core ideas of refactoring are very much the same. I mean, refactoring is all about taking these very small semantics preserving changes. I always like to say that they're so small that they're not worth doing, but by stringing together a whole bunch of these very small changes, you can actually make a very big change. And that essential process of refactoring is very much the same, and indeed many of the actual refactoring moves haven't really changed much in 20 years or so. But there are a couple of reasons that made me feel that I should think about change. One was because of the fact that just the code looks very old. It's got Java util vector over it, and I know most people watching this are probably too young to remember Java util vector.
I do remember.
And then the second,
believe you or not, I don't remember.
And if you've actually used Java util vector in the last decade, you're probably doing it wrong. Then the other reason was because also I wanted to reflect really on some of the refactorings that aren't as tied together with object orientation. I mean, Java is a very strict object-oriented language. All the refactorings were very much object-oriented based, and I wanted to at least illustrate how much of the same refactoring, of course, can be done in any kind of language, any kind of environment. So that was another reason to try and take it that well.
Yep.
So that was really the driver to do it, in the sense of if I could, do a reasonable job, hopefully I wouldn't have to touch it again for at least another 20 years.
You started saying a little bit of what is refactor, and I believe you've been stating the definition of refactoring quite a lot in the last 20 years. Could you say that again just another time and maybe emphasize a little bit of what is not refactoring? It seems to be a misuse of the term.
I mean, refactoring, sort of the definition of refactoring is that it's a change that doesn't change the observable behavior of the program. So what it does is makes a purely internal change, and the purpose of the change is to make the program easier to understand, easier to follow. And As you said, usually the changes should be individually very small. And the idea is that you move back and forth between adding new features or refactoring, so that you might do a little bit of one and then a little bit of the other, and back and forth.
Yep, and I've heard you say a couple times, and I have to agree with that. We don't refactor enough. Do you have any perspective or opinion why is that? Is that because people don't know the benefits of refactoring, or they don't know how or where to start?
It's hard for me to get a sense of exactly what the barriers are to refactoring for people. My sense is, at least part of it, is that people aren't necessarily as familiar as we'd like. But of course, even if there are plenty of people in the profession who are familiar with refactoring, I mean, there are still, every year, huge amounts of people entering the profession new. So even if everybody in the profession is really familiar with refactoring, we still need this kind of material in order to help people who are just coming into it.
Yep, that's very true. And I still remember, you know, the early days as a developer, where I used to look at my code and say, it needs improvement. I know it's not good enough, but I didn't know where to start. So on top of reading your book, do you have any other advice for people starting the journey as developers?
Well, one of the most important things to do is to practice doing it. I mean, it's like most things in software, you have to do it. It's good to find a mentor who can help you show it. I mean, obviously the book's designed to help people as much as possible, but if you have somebody who can actually show you the ropes, that can help a great deal. And of course, that's part of the aim of the book. I mean, the book is obviously there to help people who don't know anything about refactoring, but it is also there to help those who do know about refactoring pass on those skills. So it's kind of got any book like this really has that kind of dual audience. You either learn directly from it, but also a book may be valuable to help you teach. And a large part of this is also to be something that can help people when they're passing on us the knowledge and helping us in the teaching context.
Yep, there's also like a question here. How can I know that I need to refactor my code? Any thoughts on that?
Well, I mean, you need to refactor the code when, well, for various reasons, but I mean, I always find a clear indication of it is when you can't understand the code and you spend some time trying to puzzle out what some code is trying to do. Once you've puzzled it out and you've got some understanding, it's a phrase that Ward Cunningham used that I really like. It says, once you've developed some understanding in your head, you've got to take it out of your head and put it back into the code, so that next time you come through or next time somebody else comes through, they're able to read that code and understand it. Another trigger for refactoring is when you want to make a change and the existing code just isn't structured in a way that makes it easy to make that change, in which case it's often faster and easier to refactor it to make it so it's structured easy and then make that change. It's the phrase that Ken Beck says, I mean, first make it easy to change and then make the easy change. Those are the kind of things that trigger refactoring for me, either when the code isn't clear enough to understand and I gain some understanding and I want to embed that into the code, or when I want to make a change and it's easier to change first to make the put the new functionality in.
Cool. I brought one topic, which is, you know, if you could tell us what has changed and the major changes in software development from, you know, the last 20 years. And there's also like a very well voted question, which is related to, you know, not so good practices and anti-patterns that you described 20 years ago, and that seems to be common today still, which doesn't come as a surprise. But, you know, what you'd like to, you know, dangers to go for, and how to put this extra effort in eradicating those anti-patterns. So the first one is like major changes and how to actually fight against the anti-patterns.
Well, I mean, the two are kind of connected in the sense that I mean, some of the changes are many of the kind of practices that I've been advocating, and the other folks such as Kent Beck have been advocating, are more common now than they were 20 years ago. I mean, we do see people writing tests frequently. We do see people trying to develop systems by small incremental pieces. I mean, we kind of in a bubble to an extent that you find that particularly the case within Thoughtworks, and we're lucky enough to see the thing in Thoughtworks. But I think it is broader. It's certainly broader than it was, you know, as I said, 20 years ago, when we were still pushing to get anybody to do this kind of thing. But it takes time to spread across the industry generally. I mean, I'd like to see more people using approaches like the kind of testing we're talking about, like the use of things like continuous integration and continuous delivery. But as with any of these things, I mean, all I feel I can do is explain the techniques as best as I can. And hopefully that will persuade more people to try them out, and then they will experience the benefits from it, and then be able to take it from there.
And do you think that us, or, you know, as practitioners and hands-on in projects, can have like a good role on this? You know, pushing.
Yes.
I actually used to kind of passionate advocate for techniques, some of them what you already said, you know, and trying to move the team and the project forward on building the right thing, right? So you said testing, you said continuous integration. Any other techniques or practices that you think it's worth
refactoring
highlighting?
itself, obviously. The idea of building systems by small pieces and it's constant iterating to make that work, those are all part of it. I mean, coming back to what you were saying slightly earlier as you said that, I mean, it's a very important role, I think, for technical leaders to be taking on these techniques and passing them on. I think one of the most important roles of a technical leader is to mentor and upskill the members of their team. And so that's a crucially important task, and crucially important in spreading the techniques around the industry, because people learn better from a mentor than they can do just purely from a book.
Yep, and I've seen some people being like the saviors of the code base. Please try to bring people on the journey with you instead of cleaning up everything by yourself, because that's not gonna help.
Yes. Yes, well, I very much would agree with that. I mean, it's more important to show people how to fix things than to just go ahead and fix them yourself, because that just teaches people not to engage, really.
There's a good question here with, you know, couple votes, which is basically saying people have some tendency to not touch what's already working, so not refactoring, and back to we don't refactor enough. You know, what do you think it can be done to overcome this? And if you could share some of your experiences.
Well, I mean, I struggle to be. I'm not some super persuasive person. I don't try to persuade people to do things. I just try to explain how to do things, and hopefully they can then take their own direction from that. When it comes to not changing, I mean, part of it is, of course, having the kind of code base that makes it easy to detect problems when changing, which is why we put a lot of emphasis on having good tests, because they are a good detection mechanism. Some of it comes from the technical leadership of the project, showing people that it's okay to change things, and that one can only build effective stuff by iterating and building things over. But it's also sometimes the case that developers sort of lock themselves out of it. I mean, I've come across teams where developers say, "Oh, we're not supposed to change things," and then you say that to a technical leader, and the technical leader, you know, screeches in horror and says, "Oh no, I actually want people to do that refactoring." So a large part of it is it's a mix of all these things, but you want to create a culture that is used to the fact of saying, yes, we can go back and change stuff, and we have the necessary secure base in terms of the testing that allows us to detect any errors when that happens.
Cool. And what do you think about like actually saying out loud, oh, we need some time to refactor and then we can start building new features? Do you think that's compelling?
Well, it's always a balance between the two, right? You need to be adding new capabilities to the software, but you also need to be refactoring to ensure that the software retains in a healthy state, because otherwise you're not going to be able to keep adding new features. So there's always that balance in play. And I think that's one of the things that comes to judgment. I mean, like so many of these things, good judgment is really a key element. And unfortunately, there's no easy way to bottle that.
Right. So one of the questions that we have here is what are the biggest changes in comparing the first edition and the second edition? And do you want to give us a brief on that?
Well, there are some changes to the catalog in the terms of some refactorings have been taken out because I didn't feel they were as visible. I didn't feel they were as important. So an example of that is that I had refactorings to convert a unidirectional to a bidirectional association. And I took that one out because I felt it wasn't as important as some of the others. I've introduced in some refactorings that weren't there before. Some of those were because I feel mistakenly felt they were kind of too trivial to talk about. So the most obvious example of that is just moving statements within a function. I didn't have that in the original because I felt that was kind of trivial. And then I since decided that, yeah, it needed to go in. The most notable changes, though, come from the fact that I've tried my best to talk about the refactorings in a way that's not centrally object-oriented. So some of this comes down to simple renaming. So it's no longer extract method, it's extract function, things of that kind. And some refactorings that very much go with having that choice between using objects or not using objects. So there's a refactoring there for combine functions into class, which is how you take a bunch of free functions and combine them together in a class. Now, this is made most visible particularly by the fact that I'm now using JavaScript for the code examples. Although I don't see, that's the kind of change that a lot of people really pay a lot of attention to. I don't see that as a huge deal because really it's the ideas behind the refactoring and the structure of it, which really applies to any language. I mean, I may happen to pick JavaScript. That's just because I feel it's going to be a widely read language. But the basic mechanics of what you do are really the same, whatever the language that you're working in. And there's always going to be some differences between some language and another. But I think there's much more in common than there is difference.
And do you think the same applies for, changing paradigm? So, object-oriented versus functional programming?
Yeah, I don't see that as necessarily a huge shift, though. I mean, even when you're working with an object-oriented language, it's good to have first-class functions. And many functional ideas, such as trying to create large areas of your software that are referentially transparent, that's a good thing to do in an object-oriented system as it is in a functional system. So I don't see them as, people often try to make this kind of bright line between functional object-oriented. I see it as a much more overlappy kind of area. I don't see as there necessarily being a huge difference between the two. And I encourage programmers to use ideas from all sorts of places to mix into that kind of thing.
Interesting. So now that we are talking about like the context of the book itself, is there any, and you also mentioned the catalog, is there any that you would, any refactoring that you would like to call out and highlight because you're particularly passionate about, or you think everyone should know, besides the ones that you thought it was trivial and turns out that it was not?
Well, one that is probably worth a particular mention is split phase, which was a refactoring that I first really thought about as a refactoring a few years ago when I was when Ken Beck talked to me about it. And I mean, the idea behind split phase is where you've got a hunk of computation And you realize it can be sensibly divided into two phases with a data structure communicating between them. And an example of that is parsing, where it's useful to separate tokenizing from the parsing. And so that you've got a stream of tokens for the parser to deal with rather than a string of text. And the thing about this refactoring is that, you know, I've been doing it, and Kent, we've been doing it for years, but we'd never really thought of it as a thing. And then when we thought of it as a thing, then you kind of see it everywhere because you've been doing it for ages, and you realize it's something you can be much more deliberate about. So that was one of the kind of particularly, that was also, I mean, that's kind of refactoring is why you want to make a much more ongoing book, because you say, oh, damn, that should have been in the book ages ago. And so that really needed to get in there.
It's interesting that you mentioned that, because it gives us some link to talk about something that always puzzled me a little bit, which is, but if I'm splitting like a loop, what's the chance that I'm actually introducing some performance issues to my system? And can you elaborate on that, like performance versus refactoring? And is that actually a relationship, or Well,
most people, when they look at things like that, and split loop is a very good example of a refactoring that people worry about because it's going to run the loop twice. Right. Most of the time, it's not going to make a significant difference. I mean, the thing is, in most programs, it's only a small amount of the code that actually makes a big difference to the performance. And so most of the time, if you push for clarity, you're not going to change the performance of the program. And indeed, often by refactoring, you open up opportunities for performance improvements that you wouldn't even have seen had it not been well factored. So to some degree, I always say, no, worry about performance when you are refactoring. Having said that, though, you do have to keep an eye on the performance in the system, and it's a good idea to have regular performance tests and to run those tests pretty frequently. And in fact, on a lot of our projects, we have a performance test suite, and it gets run. It doesn't get run with every build because they usually take a time to run, but they do get run every day or two. And if you see a change that causes a spike in performance, then you've got to take a look at it. And it may be that it requires something that is going to be more messy in order to get around the performance. And if so, then performance does come first. But that is much less frequent than people tend to imagine. And for most of the kind of small micro changes that people worry about, they don't really have any big effect. I mean, the important thing about performance is, yes, to take it very seriously, and performance is important, but you've got to be intelligent about how you deal with performance, and it means understanding where the areas are that are critical, and you'll only find those by performance testing. You're not going to be able to just look at a program and say that's going to be slow. You're going to have to actually do serious performance tests and look at the numbers and find the hotspots that way.
Yep. Very interesting, Todd. Something that I'm, always thinking is the headline of your book says improving the design of existing code. And that reminds me of legacy systems. And I know a lot of questions are related to that. So there is indeed a book published on working effectively with legacy systems, and refactoring is a way to do that. But my question is more related to, do you see doing continuous refactoring as a way to avoid that we build legacy systems for people in the future?
Oh, yeah, definitely. I mean, if you've got a team that's regularly refactoring and is able to keep the code in a healthy state, then that stops it getting the kind of problems that we typically associate with legacy systems, or at least greatly slows down. And that's something that we certainly see. I mean, we don't have what I would call solid scientific evidence for it, but we certainly see it in terms of the judgment of many of the experienced developers that we know have really seen the effect that a regular refactoring cycle does to keeping a code base in a supple state. And that was, of course, what so much drove me to write the book in the first place. Interesting.
There's a question here, which is related to measures of quality of code and code dependencies. You started saying that you spot that's time to refactor when you don't understand. There's actually a very nice and probably well-known cartoon, which is when someone joins a room to do a code review, and they're pretty much like counting what the hell they are kind of like when they are trying to understand what the code does. I would certainly say that that's a measure of the quality of the code, but do you have any other more scientific maybe metrics from your experience?
Yeah, I think I've not seen anything that is really solid in that area. I mean, there has been some stuff that's been quite interesting around looking at code complexity areas. Certainly, it's always good to look for long functions, or just lots of lines of code in a single function is often a sign of trouble, and that correlates with things like code complexity metrics of various kinds. But I haven't made a big push in terms of numbers generally. I think to some extent we've explored a little bit of that, but it's on some of our projects, but it's not something that I've put a huge amount of time into myself.
Do you think that kind of analysis of the code base would make a good case for justifying refactoring?
Yes, and some of it, of course, is looking at it in terms of historic timing. So there's some interesting stuff done around the idea of looking at which bits of the code get regularly updated, looking at commit patterns, for instance. If you see, for instance, if you go back through your commit history in the version control system, and you see these three components are being modified at the same time in the same commit all the time, then that's an indication that they should be brought closer together. Because in general, what you want to do is have things that are modified together, brought together. Similarly, if you see some component that's being hit all the time, all over the place, that implies that there's something funny about that component, but it's been participating in all sorts of different commits. So I think you can gather a lot of information by looking at that kind of commit history. What I haven't done is really looked into this with enough depth to sort of pronounce particularly carefully on it, because again, so much to look at, so little time.
Yep. Cool. So let's go back a little bit of people who've published books, or even like some sort of good fundamentals to the industry on top of what the work that you did around refactoring. And I mentioned working effectively with legacy systems, but would you like to maybe call out any other work on that area?
Yeah, I think a particularly important piece was Scott Ambler and Pramod Sadalji's book on database refactoring, because a lot of people for a long time have seen a database as something that's being fundamentally hard to change. And what that brought out was, now you can refactor databases too. It's a bit more awkward because you've got to migrate the data as well as make changes to the schema. And that is definitely a good bit harder. But it's certainly something that you can do. And I think that's one of the most important steps for refactoring. It's something that we've really seen that make a big difference to our work at Thoughtworks. I mean, our projects regularly now use this idea of automated migrations to allow us to modify a database as we go on. And it allows us to run with a much more flexible approach at our projects. So I think that's a particularly notable example of where refactoring has extended into an area that I didn't have. And in the second edition of the book, I kind of wondered how much to do this. In the end, I haven't really done much more than other than mention that it's a thing and point to the book, because I didn't feel I could really do it justice without pointing to that separate source. I mean, if people are interested, there is also an essay by myself and Pramod on my website that talks about the technique in a bit more detail as well.
Yeah, and I can tell that's something that I came across after joining Thoughtworks, and it's definitely a big change in the way that you think about delivery and building software. So it's definitely a must read for developers out there and tech leads as well. So now that we are talking about refactoring databases and things like that, there's actually a question here about refactoring and refactoring the architecture and the components of the architecture. Do you have any thoughts around that, Martin?
Well, I mean, refactoring occurs at larger scales as well. I mean, really, you want to try, again, you're always trying to follow this notion of how do you make as small as possible changes. And I think there's actually quite a nice example of this. There's an article that I published on my site from a colleague of ours, Praful Todkar, a few months ago about extracting a data-intensive microservice from a larger system. And the interesting thing to notice about his approach is you're doing most of the moves just within the existing monolith. You're pulling the data into separate tables, you're pulling the functionality into separate bits of code. You're doing all of this within the monolith before you start firing up the external system. And then as you move stuff to a separate service, again, you're doing it in small pieces. And that sense of small deliberate steps is very much in the spirit of refactoring, even though the scale is somewhat larger.
Interesting. And is there any sort of correlation between, the architecture and how much you actually do refactor your code? I think you touched a little bit on that about, when you see a commit, which is kind of like changing different parts of the code. I would guess that the same applies to components and, architecture.
Yes, I think so. Again, because the notion is when you want things that change for similar reasons to be together. And that particularly gets more true as you move larger and larger scales, because you want to ensure that they're in the same component or in files so that easily you can see the relationship between them.
Cool, interesting. So Martin, I am very passionate technologist, but mostly about the fundamentals and the techniques. So I'd like to explore a little bit more about the practices and techniques. I've heard you say things like self-testing code and continuous integration and refactoring, of course. Do you want to go just like in a little more detail, and we could probably talk a little bit more about continuous integration, which seems to be a point of confusion out there?
You want to throw me onto that feature branch saga again? Okay. So in order to, one of the biggest barriers, I'll take that back. Certainly a significant barrier that I often hear has to do with people changing code in teams where it's going to cause big problems because of merging with other people's code paths. And this often ties up when people are using relatively long-lived branches and you develop on a branch and then you merge at the end, where that branch can live for days, weeks, or possibly even months. And this is a big issue for refactoring, because if you make a change on your branch, that can have quite a big impact on other people's branches, and you don't find out until the point that you merge. And once you get that blow up on you once or twice, it's really strong discouraging to refactor. So from the earliest days, and remember, refactoring saw a lot of its early growth in the context of extreme programming. One of the core extreme programming practices is continuous integration. And continuous integration, which some people call trunk-based development, but I use its original name, continuous integration, is the practice by which you integrate with each other fully at very regular intervals. And the rule of thumb is at least once a day. So that doesn't mean just I pull down from trunk into my branch once a day. It means I push my changes from my branch into the main line once a day, and therefore everybody else gets them. So the point is that every day you're receiving everybody else's code changes and you're pushing your own changes back. Now, the advantage of doing this is it removes the big painful merge problem. Because you're merging all the time, you're not saving it up for a big horrible crunch. It's an adage I often follow: if it hurts, do it more often. And that particularly applies with something like merging. It also means that if you do a refactoring and it clashes with what other people are doing, you find out right away, because you're detecting the potential problem within a day instead of letting it fester for several weeks before you find out there's an issue. Now, a lot of people find this really strange practice, and indeed that has been encouraged by a lot of open source development, which actually is a good place to use feature branches, because you tend to get untrusted contributors, you get people who are only programming at odd intervals. But if you've got a full-time team that's working together using continuous integration, pushing to mainline at least every day, that removes a lot of these problems. People worry about it, but what we found is that when they actually try it, people tend to find that it's much less scary than they realize, because if you're integrating every day, the pain of integration kind of goes away and it just doesn't become an issue anymore. And that sounds very hard for people because people are used to integrating being this big, horrible event. But that's because of that fact that the more frequently you do it, the pain goes down exponentially until the point where you don't have those kind of issues. But it's interesting to what extent this is still an extremely controversial practice. I was giving a couple of talks last week in Germany, and I was the person with me, Birgitta, was talking about pair programming, and pair programming, of course, is a very controversial practice. But we found it kind of amusing that people seemed more freaked out by continuous integration than they were by pair programming. But what we'd also see is that when we've seen people who've gone from a continuous integration environment to a feature branch-oriented environment, how have I noticed that really gets in the way of refactoring? And you see it affect people are just scared to refactor because they're worried about the merge conflicts that will come across. So yeah, right. Continuous integration is another thing that's really very central to encourage refactoring effectively.
Right, and it's also like the base for other things like continuous delivery and
Indeed.
Getting to production more frequently and making deploys not an event, and taking advantage of things like that to be more competitive and things like that. A lot of people here are kind of like curious and wanting and willing for your advice on how to convince business people and managers and people who think that again, if you are if it's working and it's not adding new features, you should not waste your time. On how do you think we could go about like convincing or saying and stating the importance of refactoring?
Well, fundamentally, refactoring is not something you even shouldn't really ever even talk to business people or managers about. I mean, because
I love your answer.
Are paying us. They're paying us to do a good technical job, and a large part of that technical job is including keeping the code base in a healthy state so that we can keep adding new features into the future. If we don't refactor, then we are technically failing. We are failing them because what we're doing is we're causing feature development to slow down. And it is our responsibility from an economic point of view to keep this code base in a healthy state. And refactoring is, of course, a key way of keeping the code base in a healthy state. If we don't keep the code base in a healthy state, all we're doing is stealing from our customers and our managers by doing it by slowing things down for them. So fundamentally, it is our responsibility to do that. But it's important to remember that the justification, whenever you're talking about justifying refactoring, you should never use, in my view, you should never use terms like, well, it's our professional responsibility or it's the right thing to do or things of that kind of moralistic reasoning, which I know, many people like to use, because when you do that, you've lost. The only reason to refactor is an economic reason. We refactor in order to be able to get more features out more rapidly, to be able to be more responsive to the changes that people need. And that economic reason is the reason for refactoring. And that's, by the way, why it is the right thing to do professionalism-wise, because we're being paid in order to produce features rapidly. And that's why we should think of it that way. But strictly, it's not a thing for managers or businesses, because how do they know what's fast or what keeps the code base healthy or not? I mean, that's what they pay us to do.
Right. Very well said. I'd like for us to explore a little bit more on the refactoring thinking. You mentioned the article that you published in your website recently, which goes beyond refactoring in the code level. And there is also a question here about how to bring the refactoring thinking to the service level, or even like splitting microservices and things like that.
Sorry,
so the question is more about how do you see the refactory thinking being applied beyond code, and if you have any experiences to share around that?
What do you mean by beyond code?
I mean, when you are actually like splitting your monolith in microservices or, you know, things like that. Do you think the refactory thinking could be useful in that sense, or have you seen
yes,
anything?
Absolutely. Yes.
Yeah,
I mean,
being applied. Yep.
Well, as we talked about earlier with Rafael's article, it's really about this notion of how do I get the smallest, rather than try and do one big change, try and figure out how to make it so that it's lots of little changes and then string the little changes together. That's really the essence of the refactoring thinking in applying in that kind of situation. How do we boil down a big change into lots of little changes, whereas at least as much as possible, the changes shouldn't change the overall behavior of the system. And then over time, practicing and reflecting upon how to do that breakdown. I mean, the stuff in the book is sort of my experience of thinking about through those refactorings, trying them out and deciding, well, here's a set of mechanics that will allow me to do the refactorings fairly effectively. But you do that primarily through practice, right? You try different things out, you figure out which makes a good sequence, and then you try and capture that. And that same thinking can apply to the broader level stuff as well.
Cool. So Martin, one thing is, I've seen people confused about, you know, the concept of refactoring of design patterns and solid principles. Are they actually like being mixed up, or is there a way that you can actually, you know, you start with small refactors maybe, and then realize that there is a more design pattern, or are they conflicting?
No, I don't think that. No, they don't conflict at all. I mean, a lot of the way I look at it here is with a lot of patterns, you don't necessarily want to introduce them right away because they're not appropriate, because you don't require the full strength of them, particularly some of the more complicated ones. So it's often good to refactor towards them. And you know, once you do realize you want to introduce a more complicated pattern into your system, then it's better to refactor towards it rather than trying to wedge it in before it needs to be there. So I find refactoring and patterns really fit very well together, because one is how you approach the other. And that was something that was recognized by the original design patterns authors as well. And that's indeed another book that's worth looking at if you move beyond the original refactoring book, which is Josh Kerievsky's book on refactoring to patterns, where he talks about exactly this process and how you move towards the classical design patterns through a process of refactoring.
Interesting, cool. I always had that question in my mind. Should I be looking for, you know, specific places where I can apply, you know, specific design patterns, because I saw that in a class. So we've been talking a little bit also about mentoring and bringing people's together in the journey of refactoring and good practices and, you know, things like that. Are there a specific techniques or ways, let's say like that, to do that? You mentioned pair programming. Would pair programming be one of those ways? And if so, do you see any other ways to do it?
Yeah, well, certainly I'm a big fan of pair programming. I think it's a good way for people to pass on their skills and experience, both when you think of it in terms of the classical kind of senior mentoring junior role, but even just people with different skills. I mean, there's plenty of people who are more skilled at specific things than I am. And I like to think of myself as pretty senior, but if you plot me next to somebody who's got good experience of React, I'm the junior, because I haven't done very much React programming. So I can learn a lot. So a lot of pairing is about passing skills back and forth. So there's a lot there. I think also getting a sense of smells. I mean, the reason the code smells section is in the book is because an early stage of learning about refactoring is learning to spot the code smells and say to yourself, okay, there's something wrong here. I may not know how to fix it, but if I can go to a more experienced person and say, well, this doesn't look quite right, then the more experienced person can show how to fix it. So detecting smells. And I've heard of teams that will do something like a code smell for the week and say, okay, we're really going to make a big push at long methods. You know, any function that's more than, say, 20 lines, we want to kind of be looking at that and seeing, should it be broken up? And if so, how do we break it up if it's not immediately obvious? And that can be a good way of passing on refactoring because that focuses around particular smells.
Interesting. And I particularly like the way that you phrase that you like to think of yourself as someone very senior, but when it comes to new languages or technologies, you are you may be the more junior one. It's a very, insightful thing, and
Well,
I like to think about it
like ours. It's always the way, right?
Yep. Yep. And I kind of like joke that I'm kind of like a need programmer. I'm always keen to pair and, learn from others and share my own experience. So we are getting to an end. We have around 10 minutes to go. Do you want to say, final words, any final message to our audience?
I don't particularly well, we've still got 10 minutes or so, so I'm not going to take up 10 minutes with a final message. So let's perhaps tackle some more questions, and then I can do that.
Okay, so there's one with 40 votes.
Okay.
And the question is actually, at what point would you consider a completely rewrite to a refactor?
Well, it's always, again, this is one of these things that comes down to judgment. It's hard to come up with any kind of particular parallels to that. I mean, certainly one indication of when you want to consider rewriting, for instance, might be where you're on a platform that can't move forwards, perhaps, because it's an old language or an old platform environment that doesn't really fit very well. Then in which case, refactoring, it's not going to help very much. You might as well rewrite into a more modern and supported environment. Another thing that kind of pushes you towards rewriting rather than refactoring might be a lack of tests, because if you haven't got the tests, it's going to be much harder to refactor. Now, of course, whether you're rewriting or refactoring, it's good to have tests. If you can build a set of tests that characterizes the existing behavior, that makes it much easier to rewrite it, as well as easier to refactor it. So having tests is a good route either way. But I don't think there's any kind of clear golden indicators. I suspect most people are more inclined to rewrite than to refactor. And my sense is that that's the case, but I don't really have any kind of strong evidence behind that.
Yeah, you mentioned an example of when to actually rewrite and not refactor. Do you have, more situations where refactor is not the way to go? And you should not refactor? Yeah, so the question is when...
well, I guess, I mean, another situation, I mean, if you've got an area of the code base that you never have to change, then it doesn't really matter if it's messy. Right? Because the point of refactoring is you're making the code clearer so that you can continue to make changes to it. If you've got some code that's fairly stable, contained behind its API, you never need to touch it. Then there's no point going in and refactoring it. Which is why I also say if you have got gnarly code that hasn't been kept clean, the way to approach it is don't try to clean it all in one go, but instead just try to make it a little bit better each pass through. Follow the camping rule. Always leave the campsite a little bit cleaner than how you found it. And over time, that will concentrate your efforts on the areas that most need it, which are the bits that are modified most frequently.
Interesting. Very often refactoring is brought to people's attention because of TDD and the cycle around it. From what you were saying, and with all the code smells and things like that, it's not the only way, but it's certainly an important way. Could you elaborate a little bit, give us your thoughts about the relationship between TDD refactoring when creating new features and not exactly only looking at the existing code?
Yeah, well, I mean, it's a lot of people approach refactoring through test-driven development because when people describe test-driven development, they often describe it in a term of this: write the test, make it pass, then refactor to make things clean, and using that cycle, red-green refactor, it's often called. And that's certainly necessary. I mean, if you don't do the refactor step within that cycle in test-driven development, you are going to create a mess and create a code base that's hard to work with. And that's actually Not uncommon when it comes to people when they're just starting with TDD, because they find it easier to do the red-green bit than to do the refactor bit. But the refactor bit is essential. Whoa, whoa, whoa.
Oops.
Sorry, something happened. Oh, yeah, something, yeah, sorry, that was something on this end. I think there's a, yes, for some reason the room joined in the webinar, probably because I leaned backwards on the little control panel here and caused a mess. Okay, so
Okay.
where were we?
Oh dear Lord.
What were we talking about again?
Oh, we were talking about TDD and refactoring and the cycle of.
Oh, right, and
yeah.
the cycle, yeah. So, yeah, so with the cycle, so refactoring plays an important part in that cycle, but it's also important to realize that it applies in other places as well. So I have a thing on, it's again on the website, and I've given the talk a few times. You can find the videos called Workflows of Refactoring, where I talk about how refactoring fits into different places. So a very important one, and I've kind of alluded to this early on, is where you do a preparatory refactoring. You see the code isn't quite organized in a way that would be really nice for the change you want to make. So you first refactor it to make it just right for your change, and then you make the change because it's made easier. And that's where it moves into a different place in the cycle, because that's even before you might write the first failing tests in a TDD situation. Or you might do that after you've got the tests failing, realizing the best way to get there. And then usually what I would do then is to skip those tests, take them out of the test suite, refactor, because you never refactor when you're on a failing test suite. You must only refactor on green. So you take out the new test that you just added, you then refactor to get it into the state you want it to be, and then you proceed with the rest of the cycle. So that's another way in which refactoring can feed into the TDD cycle. But they naturally go very closely together, surprise, surprise, because they came out of that same extreme programming background and developed very much by Kent and Ward and the other early small talkers that developed a lot of this stuff.
Would you say that?
And in that process, I should definitely make a shout out to many of those early developers. In particular, Ralph Johnson and his group at UIUC, who did so much of the early refactoring work. In particular, John Brandt and Don Roberts, who wrote the very first automated refactoring tool, the Smalltalk refactoring browser, which was very much the inspiration for many of the automated refactoring tools that you see now.
Would you say that if you don't have tests, you can't refactor?
For most people, I would say that is a barrier. Now, there is some work that's been done by some folks towards what they call provably safe refactorings, which is a small set of refactorings done very, very deliberately that can be done in cases. And that is an interesting route to go. I don't think it's something for most people to focus at. I think for most people, you really want to have the idea of having the tests as well. And of course, the tests aren't just good for refactoring. I mean, they're good for your whole development work as well. I mean, even when you're adding new features, you always want to make sure that you don't break what's currently there. And how do you know you don't break what you've currently got? Well, automated tests are really the big help there. So the crucial thing here is having the tests. They help you either way.
Oh, interesting. So we have 4 minutes left, and it's probably good time for us to start wrapping up this. I'd like to thank you all for your questions and attending this conversation. I hope you enjoyed as much as I did. Martin, now do you have any final considerations?
Well, there's not much really. I mean, I hope people find the new version of the book helpful. The most important thing to do with refactoring is to do it, right? So you got to practice it. You got to work at it on your projects with your teams. It can seem a bit scary, perhaps, if you haven't done it much before. But remember, the whole thing with refactoring is you take small steps, make sure you commit frequently. If anything goes wrong, you just roll back to your latest good commit. And that's what makes refactoring such a low stress thing. I mean, in a way, you can't make it too bad because anything you do, you can always roll back. I mean, that's what version control systems are there for. Yeah, go out and do it. That's the important thing.
And if I can suggest something, I would say you get the catalog, which is available in the book, and then you get each week someone in your team that could present, you know, that specific refactor and show some code that you could apply and even apply it. And that would be a good way to go through the catalog, which is quite a long catalog and interesting catalog.
Yep, that can be a way to crack at it as well. Although I think the smells are often the best way to approach things, because they focus on the outcome as opposed to the mechanism to do it. But certainly going through and familiarizing yourself with the refactorings is always a good thing to do. Okay, so then you start with the code smells, and then you find a way to get rid of it, and then you go to the catalog. That's good. So we'll be sending the recording of this webinar for everyone who signed up. So you should get that in your inbox soon. If you may not be aware, the second edition of the refactoring book is available. You can order it online, right, Martin? Yep. It is available through Informit, and I think Amazon will have it soon. It just takes a little bit of time for it to get through their systems. But Informit has it available now. When it comes to different countries, however, it's a much more complicated story, right? Because they've got to ship books around, and a lot of places they won't allow you to make the electronic version until the physical version actually gets into the country. So things can get very tangled up and confused around international stuff, and I have no idea how that applies to different countries. That's why I work with a publisher, because they deal with all of that complication. But if you do have issues, contact Informit, which is the web presence of Pearson, and hopefully they can help you.
Yep, cool. Well, Martin, thanks for your time and for the great conversation and good advice as always. And thank you all, and until next time.
Thank you. Good to talk to you again.